In this chapter, we're going to be learning how to solve something called systems of linear equations. Now, that's the name of the chapter. And there's a couple of different ways to solve systems of linear equations. We'll be going over two methods today. But systems of linear equations are pretty much two or more linear equations where we have at least two or more unknown variables. So, for example, here's a system of equations because we have two linear equations and we have two unknown variables. We don't know what x is and we don't know what y is. Same thing for the rest of these examples. So we're going to be looking at systems of linear equations, meaning two or more linear equations in which we don't know the values of x or y or whatever variables they're using. Okay, but before we start that, there's going to be three different types of scenarios that can occur when you're solving for the solution to a system of linear equations. Now, the solution, you can think of it as different ways. The solution to a system of linear equations, you can think of it as the point of intersection. You can also think of it as what ordered pair, what values for x and y can you plug into the equation to give you true statements. Either way to think about it is fine. Most people just think about what's the point of intersection. At what point do two linear equations or more intersect at? What point do they all contain? Okay. Now, if we're given a system of linear equations, of two linear equations, the first possibility that is going to happen is we're going to have one solution, in which case, if you try to graph the two equations, they'll look like this. That means that they'll have one solution, the two lines intersect at one point, there's only one single point or ordered pair of values that both lines contain, and that'll be this specific point right here. Now, there is some vocabulary that is used to refer to this type of scenario. And whenever a system of linear equations has one solution, meaning they intersect one time like this, the system is referred to as being consistent and independent. These questions are going to come up a couple of times on your homework, so I want to make sure that I get those vocabulary words down because you're going to need them. Okay. Now, in solving for systems of linear equations, it's possible that maybe you won't get any answer, you won't get any solution. There won't be a single x and y value that you can find that both lines will contain. In which case, if you graphed them, you would see that they're parallel lines. They have no solution, and whenever there is no solution, the formal vocabulary word that is referred to in this situation is the system is also called inconsistent. And I misspelled that. Inconsistent. Okay, it's an inconsistent system of linear equations. And the third scenario that can occur when we're solving for solutions of systems of linear equations, and this one's a little hard to see. Here we had one solution, meaning one point of intersection. Here we had no solution, meaning no intersections. And this last one, you might only see one line, and you might be wondering, where's the second line? Where's the second equation? It is there, but it actually is overlapping, so it's very hard to visually show you. The first line and the second line are the exact same line. They're overlapping lines. Basically, they're the same exact equation, two equations just written twice. This one basically has infinite solutions, meaning that the two lines intersect infinitely many times. They intersect here, the two lines also overlap here, over here, infinitely many times. And pretty much means that every single point that one of the lines has, the other line also has. They both have the same ordered pairs, same table of values. And this system, the formal vocabulary word, this is called a consistent, meaning it does have at least one solution. And it's also a dependent system, meaning the two lines depend on one another because they're exactly the same. Okay. So those are the formal definitions or vocabulary words of the three types of different scenarios that are going to occur when we're solving systems of linear equations. Okay. Most times we'll get one solution, but these two other scenarios do occur. Okay. Now, like I said earlier, there's actually a couple of different ways to solve systems of linear equations. We're going to cover just two methods today. We're going to be covering elimination, the elimination method, and also the substitution method. But there's so many other ways, and you don't have to know all the ways. If you find a specific way that I'm going to teach today and you like that specific way, you can just use that method all the time. So it's really just about preference and what method that you prefer to solve these types of problems, okay? But before we do an actual example of solving systems, let's go ahead and do an example of how to determine whether a solution corresponds to a system of equations. So we're given a system of linear equations, meaning we have two different equations. Both have x's and y's. We don't know what the value of x and y is. That's the kind of goal of systems. You want to know what is the value of x and y for these equations. Now the question is asking, is negative 1, 5 a solution to the system of equations below? Now it gives you a specific point, negative 1, 5. Remember, anytime it gives you an ordered pair, it always gives it to you in the form x, y. So our x value is negative 1 and the y value is 5. So if we want to figure out if negative 1, 5 is a solution to this system, well, all we have to do to see if it's a solution is we're going to take these values and plug them in for x and y into both of our equations, and if it gives us true statements for both, then we know it's a solution. So for example, let's go ahead and start with the first one. Negative 4, and instead of x, I'm going to plug in the x value they give us, which is negative 1, minus 3 times y, which the y value they give us is 5. And I want to see if it does equal, I'm going to put a little question mark because I don't know if it equals, I want to see if it equals negative 11. Well, let's do the math. Negative 4 times negative 1, that's a positive 4, because a negative times a negative is a positive. Minus 3 times 5 is 15. And we're trying to see, does 4 minus 15 equal negative 11? Yes, it does. So far, it's looking like the answer is probably going to be yes. However, we can't stop there. We checked if negative 1, 5 gave us a true statement for the first equation, which it did, meaning we know that negative 1, 5 is on the first line if I were to graph it. We also have to check, though, if negative 1, 5 yields a true statement for the second equation as well. You have to check for both equations. So I'm going to go ahead and do that as well. And so what we have, I'm going to do it out to the side. Negative 5 times x, which the x value they give us is negative 1, plus 3 times y, which the y value they give us is 5. And I want to see, I'm going to put a question mark because I don't know if it actually does. I want to see if it equals negative 61. So let's do the math. Negative 5 times negative 1 is a positive 5, plus 3 times 5 is 15. And we're trying to see, does 5 plus 15 equal negative 61? And no, it does not. So the answer, the overall answer is no. Negative 1, 5 is not a solution to this system of equations because it did not give us a true statement when we plugged in the x and y value to the second equation. It has to give us a true statement for both. If both of these answers were yes, then the overall answer would be yes. But it does not work for the second equation, so the overall answer is no. Negative 1, 5 is not a solution to this particular system of equations. Okay, I'm going to bubble that as well. Okay. All right, we just did an example on how to determine if a specific point that they give us is a solution to a system of equations. And we got no for this particular example. What we're going to do now is, well, we know negative 1, 5 is not a solution. Well, what is the solution? What does it have a solution? What is the specific point of intersection? So we're going to go ahead and do that. See, it's the same exact problem, but now we're actually going to find the actual solution. And I'm going to go ahead and start by going over something called elimination. I've also heard it referred to as addition method, but I'm going to go ahead and go over the elimination method to solving systems of equations. And personally, I use this method always. This is my preferred method for all systems. I know there's a couple of other ones, and I'll go over one more, but I like to use this method always, and that's just my personal preference. Okay, so let's go ahead and do this specific example. I want to know, basically the goal is to figure out what does x equal and what does y equal. That is the goal of this problem. So my ultimate goal is to figure out what is x and what is y. Okay. What x value can I plug into both of these equations and what y value can I plug into both these equations that'll give me true statements for both. Now, I'm going to go ahead and use the elimination method, and what I want you to do is just by looking at this equation, and notice that everything kind of lines up nicely, which is nice and key. I want you to look at these two equations and try to see if you see anything that they have in common, any similarity between the first equation and the second equation at all. Okay. And most people can easily see, well, the only thing that they seem to have in common is they both have 3's as coefficients of the y. See how the first equation is minus 3y, and then right below it the second equation has a plus 3y. Those are pretty much, they have that in common. They pretty much are inverses, negative 3, positive 3. And that kind of works to our advantage because if I were to, I don't know what x is and I don't know what y is, and it's hard to solve them at the same time. But if I were to take these two equations and add them, that's why I've also heard it referred to as the addition method. What we would end up with is we would end up with some cancellations. We would have, let's add everything up, negative 4x plus negative 5x. Well, negative 4 plus negative 5 is negative 9x. And then we would have negative 3y plus 3y. Well, negative 3 plus 3 is actually 0. So those actually cancel out, and we don't have any y's now. And we're going to bring down the equal sign. And then I have negative 11 plus negative 61. Just add those two numbers, and you should get negative 72. And that was really useful because now, instead of having two unknown variables that I don't know what they are, I have this new equation, and all I have is x, and I can easily solve for x now. This is a basic one variable equation. So we have negative 9x equals negative 72. Just solve for x. Negative 9 is being multiplied by x, so I'm just going to divide both sides by negative 9. Negative 9 divided by itself is just one whole, so those essentially just cancel out. And we are left with x equals negative 72 divided by negative 9 is a positive 8. And what do you know? We already know the value of x. It is equal to 8. Okay. Now that's not the full answer. We're almost done. We know what x is, but the goal is to figure out what is the value of x and y of the solution. We know what x is, so how do we find y? Okay. Well, if you know what x is, all you have to do is take this x value that you already know is the answer, and you can plug it into either equation to figure out what y is. You can plug it into the first one or the second one. It doesn't really matter. I just do the first one because it's the first one I see. I'm going to take negative 4, and instead of x, we know what x is. It's 8, so I'm going to multiply it by 8. Minus 3y equals negative 11. And I have an equation that just has y, so I can easily solve for this now. Negative 4 times 8 is negative 32. Minus 3y equals negative 11. I'm trying to solve for y, so I'm just going to go ahead and add 32 to both sides. Okay. Negative 32 plus 32, those cancel out, so you can kind of just cross them out. And you're just left with negative 3y, don't forget that negative, equals negative 11 plus 32, which is 21. And then lastly, we're trying to get rid of this coefficient. Anytime you have a coefficient, you want to get rid of it, you just divide. Negative 3 is being multiplied by y, so we're going to divide by negative 3 on both sides. Negative 3 divided by itself is just one whole. They essentially cancel out. And we are left with y equals 21 divided by negative 3, which is negative 7. And there's our y value of the solution. And this is our one solution. So this system of equations does have a solution, and it is 8, negative 7. Okay. Now you can leave it like this. You could also write it as an ordered pair if you wanted to. You can also write it as 8, negative 7 if you want to write it as ordered pair. That's also fine. It's the same thing. Now that was our answer. What is a way that we could check that this answer was correct? I mean, I know we did everything pretty neat and organized, but how could we double check that this answer was correct? Okay. Well, we could do the same thing we did on example 1. We would just take our answer, 8, -7. We would plug it into both equations and make sure it gives us a true statement for both of them, just like we did example number 1. So you could easily check any of these problems by doing this same method on example number 1. All right, moving on, we're going to go ahead and do some more examples. But that was how you solve a system by elimination. Okay. All right, next example, we have another system of linear equations. We have 2 equations. We have 2 unknown variables. We don't know what x is. We don't know what y is. And it says find the solution to this system. In other words, figure out what x value and what y value can you plug into both of these equations. That'll give you a true statement. Okay. All right, we're going to solve it. Now, on the last problem was really nice because one had a -3y and one had a +3y. So all we had to do was add them, and they just canceled out. It worked out so nicely. It was set up so easy for us to just add the 2 equations, and the y's canceled out. But if you look at this next example, nothing cancels out right off the bat. We have a 2x and a -4. If I add those 2 numbers, it will not be 0. We have a 1y and a 6y. If I add those, it'll be 7. I want it to be 0. So we don't have any variables that would cancel out off the bat. Nothing that'll eliminate. And we do want to get that cancellation happening. Well, nothing's going to happen right off the bat. However, we can make things cancel out. We can take one of these equations and multiply it by something, and then we'll get some cancellations. Okay, now what do I mean by that? Well, first, you need to decide, do you want to cancel out the x's or the y's? And honestly, it doesn't matter. There's so many different ways that you can approach this, but just pick one. Do you want to cancel out the x's or y's, and then go from there. I'll go ahead and cancel out the x's. Okay. Now, one of them is 2x, and the other one is -4x. I didn't say this, but make sure everything lines up. We have the x's lined up, the y's lined up, the equal signs lined up, and the constants. And we want to cancel out the x's. Well, in order for that to happen, we need to have inverse numbers, like, for example, -3 and +3, or -5 and +5, or -10 and +10. Basically, 2 numbers, one negative, one positive. And right now, we have a +2 and a -4. Well, that's not going to cancel out, but if I had maybe a +4 and a -4, then that could cancel out. So right now I have 2x. What could I multiply 2 by so that it'll equal +4? Because if I add +4 to -4, it'll cancel out. Well, 2 times blank is +4. Well, 2 times 2 is +4. So what I'm going to do is I'm going to take this first equation, and I'm going to multiply it by 2. Now, whatever you do to just x, you have to do to the entire equation. So what I'm going to have now, I'm going to have 2, and I have to multiply it by everything, times 2x, and that gives me 4x. Then I'm going to multiply 2 times +y is just +2y. And then a lot of people forget to do this step, but also multiply the 2 by the constant. So 2 times -1 is -2. Now notice I didn't change the second equation. I'm just going to rewrite it again. -4x plus 6y equals 42. I didn't change the second equation. And the reason why I multiplied the first equation by 2 is because now if you look at the x's, if we add them up, they will just cancel out, just like we had in the previous problem. That's exactly what I'm going to do. I'm going to take my system of equations, and I'm just going to add up the 2 equations now. And what I will have 4x plus -4x. Well, that's 0x. Those cancel out, so those just go away. I will have 2y plus 6y. That's 8y. And then I will have -2 plus 42. That's 40. And now I can easily solve this. This is just a 1 variable equation. I'm just going to solve for y by dividing both sides by 8. 8 times what is 40? And 8 divided by 8 cancels out. That's just 1 whole. And our y value is 40 divided by 8, which is just 5. So we know the y value of this solution is 5. All right, we know the y value is 5, but what about the x value? In order to find the full answer, we need to know what's the x and y value. We've done the hard part, though. Once you know one of the variables, you can easily just take that answer, plug it into one of the equations, and figure out what the other variable is. Now, here's the problem. Where do I plug in y equals 5? Do I plug it into the original first equation, the second equation, the new and improved first equation? And honestly, it does not matter. You can plug it into any of the equations that we have above, and it'll all give you the same answer. So that's pretty nice. I'll go ahead. I always just plug it into the first one I see. So I'll go ahead and do that. So we have, I'm going to go ahead and plug this into the first equation, and that'll give me 2x plus y, which we just said y was 5, equals -1. And then I'm just going to solve for x. So let's see, I have a plus 5. I'm just going to subtract 5 from both sides. Running out of space here. 5 minus 5, those cancel out. And I'm left with 2x equals -1 minus 5, which is -6. And then you solve for x by dividing by 2. So basically 2 times what number is going to give you -6, which you might already know. But I'm going to divide by 2. 2 divided by 2 cancels. And x equals -6 divided by 2, which is -3. So our x value of the solution is -3. And this is our solution. Oh, you can't see that. Or you could write it as an ordered pair if you want to write it as -3, 5. Same thing. Okay. This just means that if you plug in -3 for x and 5 for y to both equations, they'll both give you a true statement. And in other words, -3, 5 is a point on both of these lines if I were to graph both of those lines. That's the point that they have in common, the one point they have in common. Okay. And that's the elimination method. So if you like that method, that's fine. You can stick to it. You can use it for all the problems, and that'll work just fine. And I'll kind of go back to that method maybe in just a bit. But I do want to show you another method. If you didn't like that method, I want to show you one more method. Some people might prefer this. So I'll go ahead and just do an example, just one example on another method called the substitution method. Now notice it is the same exact problem, because no matter what method you use, you'll get the same answer, so it doesn't matter. But for those that maybe just didn't like that method, I can show you this other method as well. So it's the same exact system of linear equations, and it says find the solution. So what point do they have in common? What point do they both carry on their line? So I'm going to go ahead and solve this problem, but I'm going to use the method of something called substitution. Now what that means is you're going to pretty much use one of the equations and substitute it into the other. Okay. So I have my first equation, and it doesn't matter which one you pick to start with, but I'll pick the first one. And essentially, you want to solve for either x or y. It doesn't matter which one. Let me just rewrite it over here. 2x, I'm using substitution, plus y equals -1. And I want to solve for either x or y. It does not matter. I'm probably going to solve for y here, just because it looks like it would be easier to solve, because y's are by itself. So I'll probably solve for that one. So the way I would solve for y, I'm just going to go ahead and subtract 2x from both sides. 2x minus 2x, those cancel out. And I'm left with y equals -1 minus 2x, or -2x minus 1, either way. So you know that y is equal to -1 minus 2x. Now we still don't know what y is, and we still don't know what x is. However, we know that y by itself is equal to -1 minus 2x. So what you can do with that, you can take this y value and plug it into your second equation. So what I would do is I would take the second equation, and then I would, let me go ahead and bring it down, -4x plus 6. And instead of y, I'm going to go ahead and replace it with what y equals, which is -1 minus 2x. Because y equals -1 minus 2x. Equals 42. And what you've done is you pretty much just made an equation into just x's, just one variable, and you can solve that now. negative 4x plus, we'd have to distribute 6 times negative 1 is negative 6. Oh, I should have just left off let me just leave off that plus sign, minus 6. 6 times negative 2x is negative 12x equals 42. And then we would just combine like terms. Negative 4x minus 12x, that's negative 16x. We still have this minus 6. I'm trying to solve for x, so I would add 6 to both sides of the equation. Minus 6 plus 6, those cancel. And I have negative 16x equals 42 plus 6, that's 48. And then lastly, you want to divide both sides by negative 16. So negative 16 divided by itself is just one whole. So let's cancel out. And 48 divided by negative 16 is negative 3. So you know that the solution has an x value of negative 3. And then if you want to figure out what y is, same process as the other method. You would just take this answer, plug it into any of the equations. It doesn't matter which one. You can plug it into the first equation, the second equation, this other equation we saw for. It doesn't matter where you plug it in. I'll probably just plug it in here because it's written right there, nice and neat. So y is equal to negative 1 minus 2 times x, which we just said x was negative 3. And then negative 1 minus 2 times negative 3 is positive 6. And then negative 1 plus 6 is positive 5. So our y value is 5. Which, what do you know, that's the same exact answer we got on the previous problem using the elimination method. So again, you can use either method. I prefer elimination. I just feel like it has less writing. Look how much I wrote there, and I feel like I wrote more here. But it's up to you. So if you want to use substitution, you can. There's a few problems on the homework that'll say use substitution if you want to, but you don't have to. You can always use elimination. And that's it for that one. All right. Okay. So we're going to go ahead and do a couple more just practice examples. I'm going to stick with the elimination. I just kind of want to stick with one method for the rest of these. So I'm going to stick with elimination for the rest of these, but you can totally do substitution if you like that one better. So let's go ahead and do some practice examples. Example number 5, it gives me a system of equations, and it says find the solution if there is one. So I'm going to go ahead and try to figure out what is x and what is y, and that's the goal of all of these problems. Okay. Well, if I'm using elimination, first make sure everything lines up. The x's line up, the y's line up, the equal signs line up, and the constants line up. And if they don't line up, make sure that you rearrange them. But they do. And then next I'm going to look, is there any just immediate cancellations? Just like that first problem. Remember how it was just nicely set up? If we just added the two y's, they canceled out. So I'm going to see if there's anything like that happening here. We have 2x and a negative 1x. And that's not going to cancel out. That's not 0. We have a 3y and a 1y. 3 plus 1 is not 0. So nothing cancels out. But that's okay. We can make one of them cancel out by multiplying. Now it doesn't matter which one you want to cancel out. If you want to cancel out the x's, you want to cancel out the y's, it doesn't matter. If you want to cancel out the y's, that's totally fine. If you cancel the x's, again, that's okay. You can pick whichever one. I'm going to go ahead and pick the x's just because it's the first one I see. So I want to cancel out the x's. I have a 2x and I have a negative 1x. Remember, when there's no number in front of it, it's a 1. You can write it there if it helps. I want that to cancel out. We have 2 and negative 1. That does not add up to 0. If this was 2 and negative 2, that would add up to 0. So I want this to be a 2 and a negative 2. So the first equation is good. The second equation, I want that to be a negative 2. So what do I have to multiply negative 1 by to equal negative 2? Well, you have to multiply it by 2. So that's exactly what we're going to do. But you have to multiply it by the entire equation. So our first equation doesn't change. I'm just going to rewrite that over here. 2x plus 3y equals 1. And our second equation, we're multiplying everything by 2. So we have 2 times negative 1. X is negative 2x. 2 times y is positive 2y. And 2 times negative 3 is negative 6. And I did that because now if you look at the x's, if we just add them up, that's why you might have heard it called the addition method. If we just add up the two equations, we're going to have the x variables cancel out. 2x plus negative 2x. Well, that's just 0x. Those cancel out. 3y plus 2y, that's 5y. 1 plus negative 6, that's negative 5. And now I can just easily solve for y. I'm going to divide both sides by 5. 5 divided by 5, that's just 1 whole. And we have y equals negative 5 divided by 5, which is negative 1. And there's part of our answer. The y value of this solution is negative 1. Okay. It's not the full answer. We know what y is. We just have to figure out what x is. So what we're going to do is we're going to take that answer and we're going to plug it into any equation. We can plug it into the original first one, the original second one, the new and improved second one, any equation, and you will get the same answer. I'll go ahead and just plug it into the first one that I see. So I'm going to go ahead and plug it in to 2x plus 3. Instead of y, I'm going to plug in negative 1 because we just said that y is equal to negative 1 equals 1. And I'm just going to solve for x. 2x plus 3 times negative 1 is negative 3. I'm going to add 3 to both sides of the equation because I'm solving for x. Negative 3 plus 3, those cancel out. And I have 2x equals 1 plus 3 is 4. And then 2 times what number is going to give you 4? Well, 2. And so our solution has an x value of 2. And there's our answer. You can always double check that this is correct by plugging both these numbers in to both equations, and you should get true statements for both. All right, moving on to example 6. Now, this one, I'm going to go ahead and solve it using elimination as well, but I want you to note that you won't always get a clear-cut solution answer. Sometimes you get something funky, and I'll go ahead and tell you what to do in those cases. So example number 6, I'm going to use elimination again. Right off the bat, just make sure everything's lined up. The x's are lined up, the y's are lined up, the equal signs are lined up, and the constants are lined up. Now, right off the bat, though, I don't see any cancellations, meaning like if I add the two equations, 2x plus 4x, that won't be 0. 1y plus 2y, that will not be 0, it'll be 3y. So I do want to change one of them so that I can get some cancellations. I'll go ahead and I'm going to cancel out the x's. You can do the y's if you prefer that instead. I have a 2x and I have a 4x. I want it to add up to 0. If this was maybe a negative 4 and a positive 4, that could add up to 0. So if I want to make positive 2, I want it to be a negative 4x. What do I have to multiply 2 by to equal negative 4? Well, I'd have to multiply it by a negative 2. So I'm going to do that. I'm going to multiply the whole first equation by a negative 2. Now, why am I doing that? Because negative 2 times 2 is negative 4, and negative 4 will cancel out with a positive 4. So let's go ahead and multiply. Negative 2 times 2x is negative 4x. Negative 2 times 1y is negative 2y. And negative 2 times 5 is negative 10. Now, I did not change the second equation, so I'm just going to rewrite it over here. I have 4x plus 2y equals 8. All right, I want to now add up the two equations so I can get some of the variables to cancel out. And what's going to happen here is we're going to have negative 4x plus 4x. Well, that's 0x. That's what we wanted, so that's kind of nice. And then we have negative 2y plus 2y. Hey, that's also 0. So essentially, we have nothing left on the, everything canceled out. The x's and the y's both canceled out. Essentially, we have 0 items left. We don't have anything on the left-hand side of the equation. On the right-hand side, we have negative 10 plus 8, which is negative 2. And this is what we're left with. This is first off, this is a false statement. 0 does not equal negative 2. And everything canceled out. The x's canceled out, the y's canceled out. Now, when this happens, when everything cancels out and you're left with a false statement, what that means is that there is no solution. There is no solution. In other words, if I were to graph the two lines, they would actually be parallel lines. They have no points in common. There's no x and y value that you could ever plug into either of these two equations to give you true statements for both. There's not. They don't have any points in common, no x and y values in common at all. It's not possible, and that's why this kind of funky thing happens. In other words, there's no solution. Okay? All right. In other words, it's inconsistent, if you want to use that vocabulary word. All right. All right, and then example number 7, we want to find a solution to the system of equations. So let's go ahead, and I'm going to still use elimination method. So right off the bat, everything's lined up. If I try to add up the two x's, 2 plus negative 6, that's not going to give me 0. 1y plus negative 3, that's not going to be 0, that's going to be negative 2. So nothing's going to cancel out right off the bat. Most of the time it doesn't, and that's okay. But we can change one of them so that we can get some cancellations. Doesn't matter which one you want to cancel out first. I always just cancel out the x's first, but you can also do the y's instead. We have a 2x and we have a negative 6x. Right now that does not add up to 0. If this was a positive 6 and a negative 6, that would add up. So again, if I wanted this to be 6x and negative 6x, I'd have to multiply 2 by something to be a positive 6x. So what can I multiply 2 by to get positive 6? Well, then I have to multiply it by 3, because 2 times 3 is 6. So I'm going to multiply the whole first equation by 3. So we're going to have 3 times 2x is 6x. 3 times y is positive 3y. And 3 times 4 is 12. Now notice I'm not changing the second equation. I'm just going to rewrite it right underneath. Okay. And now, if I add up the two equations, I will get some cancellations. 6x plus negative 6x. Well, that's 0x, so those cancel out. 3y plus negative 3y. Well, 3 plus negative 3 is 0y, so those also cancel out. So once again, we have 0 items left on that left-hand side. And on the right-hand side, I have 12 plus negative 12, which is 0. Now, all the x's and y terms canceled out like they did previously. However, this is actually a true statement. 0 does equal 0. So when everything cancels out, all the x's and y terms cancel out, you can't actually solve anything. But you're left with a true statement, because 0 does equal 0. That actually means that there are infinite solutions. That, in other words, means you can pick any x and y coordinate value. You can plug them into both equations, and they'll give you a true statement for both of them. Okay, so let me look right here. If I were to graph the two lines, they would look like this. They're pretty much, these are the same exact equation, they're the same line, they overlap, they have infinite solutions. They have every single point in common. Okay, so think of an ordered pair that will give you a true statement for the first one, and we know it's going to give you a true statement for the second one because they're the same line, essentially. Okay. So these two last examples, I know these are very similar, but they are different answers, so just make sure that you know the difference. False statement, no solution, and true statement means infinite solutions. Okay. All right, last page. All right, example number 8. So we've done a couple of examples of systems of equations. Now, where does this come into play? Where does this apply? What's an application that we could apply this to? Well, that's actually very easy. There's a lot of problems that we can make systems of equations with. So let's go ahead and do a word problem. And this is just an example of a system of linear equations in the real world. So a movie theater selling tickets for $10 each, which seems about right because movie theaters are right at that price. Senior citizens get to receive a discount price of $8. So they get $2 off. One evening, so on a specific night, the theater sold 525 total tickets, meaning regular tickets and senior tickets. There was 525 tickets total. And it took in $4,630 in revenue. So that's how much money they made in just that one night. How many of each type of ticket were sold? So just based on this information, how many regular price tickets were sold and how many senior citizens tickets were sold? Well, what I'm going to do first, I'm going to create a system, but the first thing I'm going to do is I'm going to write down what do I want to figure out. I want to figure out how many type of each ticket was sold. So I'm going to make some variables. I'm going to go ahead and write X, and I'm going to say X is the number of regular price tickets sold. Priced. And Y is going to be the number of senior citizen tickets sold. So how many regular people came in, or regular price people came in, and then how many senior citizens came in that specific night. So I want to know what is X and what is Y. That's the goal. How many of each type of ticket were sold? There's two types of tickets. Well, I'm going to create a system out of this. What's one thing we know? Well, we know that the regular price tickets are $10 each. So what I can do is I can create a system, $10 for every regular price ticket. So 10x. Okay. I also know that the seniors have a ticket price of $8. So $10 for every regular priced person and $8 for every senior priced ticket. 8y, and that equals, well, what do we set it equal to? Do we set it equal to 525 or 4630? We'll look at what we're talking about. We're talking about money. $10 for every ticket plus $8 for every senior ticket equals $4,630. $4,630. The units have to match. Money, money, money. Okay. A lot of people will make the mistake of setting this equal to 525, and that is not true. We're talking about money here. $10 for every ticket that was sold regular price plus $8 that was sold for every senior is equal to $4,630 total. Money, money, money. The units match up. Okay, so there's our first equation. In order to get a system, though, we need a second equation. We only have one equation. So what else do we know? Well, we also know that there was a total of 525 tickets sold. So we don't know what X is and we don't know what Y is. However, we do know that there's 525 people total. So we can write a second equation. We know that X is all the regular price tickets and Y is all the senior citizen tickets. And we know that in total there was 525 tickets sold. Okay, we're not talking about money here. This is just how many regular price people came in and bought a ticket, how many senior citizens came in and bought a ticket, and this is how many people there were total. Okay, so we have two equations. This is called a system of equations now. And what I can do is now I'm going to solve this system of equations using elimination, or you can use substitution if you prefer that method. Okay, now everything's lined up, so that's nice. Next thing I'm going to look at to solve it is I'm going to see if there are any terms that are going to cancel out by adding the two equations. 10x plus 1x, no, that'll be 11. I want it to be 0. 8 plus 1, that'll be 9. I want it to be 0. So nothing cancels out right off the bat, but we can change one of them so that'll happen. So let's go ahead and look at, I like to cancel out the x's, but you can do the y's. 10x and 1x. I want it to add up to 0. Well, it would add up to 0 if this was a 10x and this was a negative 10x, because 10 plus negative 10 is 0x. So the first equation's good as is, 10x. What do I have to multiply this second equation? X. Remember, there's a 1 if you want to put a 1 in front of it. What do I have to multiply 1 by to equal negative 10? Well, I could multiply it by negative 10. That's exactly what I'm going to do. So my second equation will be negative 10 times 1x, which is negative 10x. Negative 10 times y is negative 10y. And negative 10 times 525 is negative 5,250. Just add a 0. Okay. Now the first equation, I didn't change the first equation at all, so I'm just going to rewrite that right on top. 10x plus 8y equals 4630. Okay. All right, and now that I have my new and improved system of equations, I'm going to add these two equations up and see what happens. 10x plus negative 10x. Well, that's 0x. Those cancel out. 8y plus negative 10y. That is negative 2y. 4,630. I'm going to use my calculator for that. 4,630 plus negative 5,250, and that is negative 620. Okay. And then I'm just going to solve for y. Negative 2 is being multiplied by y, so I'm just going to divide both sides by a negative 2. Negative 2 divided by itself, those cancel out, that's just one whole. And y is equal to negative 620 divided by negative 2, which is positive 310. So what does this mean? Well, this means that there was a total of 310 senior citizen tickets sold that night. Okay. We know what y is, though. We do also need to figure out what x is. So we know that 310 senior citizen tickets were sold. What about regular price tickets? How many regular price tickets were sold? Well, we can do what we've been doing. We just take our answer and plug it into any equation that you want to. You can plug it into the first equation, the second equation, the new and improved second equation. It doesn't matter. I'm actually going to plug it into this one right here just because it looks like the simplest. But it doesn't matter which one you plug it into. So I'm going to take this answer. I'm going to just over here. X, which we don't know what x is, plus y, which we just said y was 310, equals 525. And I'm just going to solve for x. Subtract 310 from both sides. 310 minus 310, that'll just equal 0. And we have x equals 525 minus 310, which is 215. And that means that we had 215 regular priced people or tickets that were sold. And there's our final answer. There's our solution. Oh, you can't see that. Sorry. Okay. All right. All right. Moving on. Last example. All right, the last example, number 9, this one's actually a solution or system of 3 linear equations. So like I've been saying, even in the definition, a system of equations is just 2 or more. Now, normally, we really only look at 2 equations. We won't actually solve anything that has 3 or more equations, but they are still considered a system of linear equations. It just means you have more than 2 equations and more than 2 unknown variables, in this case x, y, and z. So there's a little bit more work, but again, we're not going to actually solve it. For this example, we're just going to figure out, is the point 2, negative 2, 1 a solution to this system of equations below? Now we have 3 variables, x, y, and z. So the ordered pair that they give you is 2, negative 2, and 1. That's just x, y, and z. You can label it as such. And if you want to figure out if a point is a solution to a system, you can just do what we did on the very first example, which is take that number and just plug it into both equations and see if it gives you a true statement for both, or for, in this case, all 3 of them. So that's exactly what I'm going to do. I'm just going to take 2, negative 2, and 1 and plug it into my first equation. And I will get 3 instead of x, I'm going to plug in 2, plus 3 instead of y, I'm going to plug in negative 2, plus 4 instead of z, I'm going to plug in 1. And I want to see, I'm going to put a question mark, I want to see if it equals 8. So let's see, I'm actually going to use my calculator to help me save some time on some of the math. 3 times 2 plus 3 times negative 2 plus 4 times 1, and oh, it does not, it actually gives me 4. So I actually know that this does not equal 8. Now essentially, If it did give you a yes, you would have to check the other two equations as well. Make sure they give you true statements for all of them. But I don't even need to go that far. I already got a no, so I already know overall that 2, negative 2, 1 is not a solution to this system. And there you go. I think there is one in your homework that's like that. So, okay. All right, and that's it for this chapter.